So this is 3.4, and we're going to be using division to do the remainder theorem. Okay. So find a polynomial of degree 5 that has the following zeros. So if x equals -5, what is the factor that created that root? So we have x equals 5, x equals 8, 7, 0, and 1. So I want to create a polynomial where I multiply all of these factors together. What factor creates x equals 5? X minus 5. Oh, sorry, this is negative, so that should be positive. Good job. Glad you're paying attention. And then x minus 8, and x minus 7, x, and then x minus 1. If I were to graph that, oh, hold on. Turn this off. All right, so if I did x plus 5, sorry, x minus 8, x minus 7, x, and x minus 1, and I were to graph that, it's going to look really, really steep because I'm multiplying many, many numbers together. So if I go in here, and then I times it by like 0.01, now I've crunched the graph vertically. I could even go further than that. 0.05. Now you can see you can build a polynomial that hits the x-axis anywhere you want. And then by changing the number you multiply it by, we can essentially create any function we want using polynomials, which is the whole reason why we study polynomials. What? So what you would do, let's say, let me answer the phone. So let's say you were modeling some, like you took a whole bunch of data and you created this equation and it looks like this. And you wanted to know what is the equation of that graph. Well, if it could be written lots of different ways, but one of them could be a polynomial. So, right, if I kind of built a polynomial and I know it has to hit there and there and there, then you can build an x to the 100 that looks really, really, really close to that. It's probably not going to be perfect, but if you did an x to the 1,000, it's going to be more accurate. If you did an x to the 1,000,000, it's going to be more accurate. And it turns out that most of the time, x to the 1,000,000 equation, even though it's really long, it ends up being much easier to work with than the actual equation, which might have trig and other messy things in there. So this all has to do with calculus. We're using polynomials because calculus on polynomials is super, super simple. All right. We did that in the last one. All right. Who's making noise? Is that me? Oh, me. I'm making noise. All right. So I want to know, is x plus 1 part of that equation? Is it a factor? Well, what if I had 2,492 and I wanted to know, is 3 a factor of that? How would you tell? What? Divide. All right, so 2,492 divided by 3. Is it a factor? No, why not? It didn't go in evenly, right? If I did long division, how would I tell if it went in evenly? If it didn't have a remainder. So if I divide this by 3, I get 8, 24, so 3, 3, and that would be 9, 0, 2. How many times does 3 go into 2? It doesn't. So I get 8, 30, remainder 2. So if you divide and you get a remainder, that means that that whatever you divided by is not a factor. So let's do this division. So x plus 1, negative 2x to the 4th. What goes up here? Negative 2x to the 3rd. And this would be negative 2x to the 3rd. Those need to add up to be, so it needs to add up to be negative 2x to the 3rd. I already have negative 2x to the 3rd. So 0x to the 3rd, pull out an x, 0x squared. So this would be 0x squared. These need to add up to be 0. There is no x squared term in the numerator. So 0x squared, pull out an x, 0x, 0x. These need to add up to be 3x. I'm at 0, so I need a 3x, plot a 3. 3 times 1 is 3. These two need to add up to be 3. So the division is, it went in evenly. Right? Now, that was really long. Is there an easier way to do that? We could use synthetic division. Right? So with synthetic division, if x plus 1 is my factor, what do I put in the corner? Negative 1. What are my coefficients? Negative 2, 0, 3, and 3. Okay? Negative 1 times negative 2 is 2, 0, 0, 0, 0, 3, negative 3, 0. Okay? How do I know it went in evenly? There was no remainder. Okay? Yeah, I'll show you in just a second. So what if I divided by x, x minus 2? Okay? Let's do synthetic division and see what happens. So what goes in the corner? 2. Okay? So negative 2, 0, 3, and 3. Drop the 2. Negative 2 times negative 2 is negative 4. Negative 2 minus 4 is negative 6. Negative 12, negative 12, negative 24, negative 21. This is getting nasty. Negative 42, and negative 39. Did that go in evenly? No. The remainder is negative 39. What does this number actually tell us about the graph? Well, let's plug in 2 into this equation and see what happens. So if I type in, come on. All right, so negative 2 times 2 to the 4th minus 2 times 2 to the 3rd. Oops. Okay, plus 3 times 2 plus 3. Look at that. So what is the significance of negative 39? It is the remainder when you do the division. It's also the y value corresponding to x equals 2. So whatever this graph looks like, right? When I go over here to x equals 2, oh, I graphed that wrong. So when I go over here to x equals 2, the y value is negative 39. So how do you find out whether or not x plus 1 is a factor? The easiest way is just to plug in negative 1 and see what you get. So what is p of negative 1? So we just stick negative 1 in there, in there, in there. So we get negative 2. What is negative 1 to the 4th? Just 1. Okay. Minus 2 times, what is negative 1 to the 3rd? Negative 1. Okay. Those cancel, and those cancel, and I get 0. What does 0 mean? It means that the graph hits the x-axis at negative 1. And it also means when you divide by x plus 1, you get no remainder. So when you do division, the remainder is equal to the y value corresponding to the x value for that factor. So there are 3 different ways to do that. The easiest way is to plug in the number. If the answer is 0, then yes, it is a factor. All right. So let's do the division. If I want to know when x is 1, we just have to do synthetic division. So negative 1 goes in the corner. 2, 2, negative 5, 0, and 8. Drop the 2, negative 2, 0, 0, negative 5, 5, 0, and, oh no, 5, 5, negative 5, and 3. Okay, so what is my quotient? I started with an x to the 4th. So 2x to the 3rd minus 5x plus 5. What is my remainder? 3. And what happens when you plug negative 1 into the function? You get 3. So the graph hits negative 1 comma 3. Okay. All right. And lastly, all right. So dividing the polynomial p of x by x minus 2 yields a quotient and a remainder of 10. If the quotient for negative 2 is 6, sorry, if you plug negative 2 into the function and get 6, find p of negative 2 and p of 2. So p of 2 is going to be what? So if I take p of x and I divide it by x minus 2, I get some equation, remainder, what? 10. Right? That's what it says. If you divide p of x by x minus 2, you get a new function and a remainder of 10. Okay? So this function right here is q of x. Does everybody understand that? So what is p of 2? It has to be 10, right? If I plug 2 into this function, that is exactly the same thing as dividing by x minus 2. So this is 10, right? Okay. Well, I know when I plug negative 2 in here, the answer I get is 6. So q of -2 is 6. Right? Okay. So what is p of -2 going to be? That's a little harder. So let's think about this. P of x divided by x minus 2 is equal to q of x plus 10 over x minus 2. Does everybody understand that? So I took some equation, I divided it by x minus 2, I got a new function with a remainder of 10. Right? Well, I know that q of -2 is 6. Right? And these are both x. So if I plug this in here, I can replace that with a 6. Right? So that gives me p of x over x minus 2 is equal to 6 plus -10 over x minus 2. Well, I want to know what is p of 2. So if I put a 2 in there, then that would put a 2 here and a 2 here, and then I could just solve and figure out what it is. Oh, that's going to break. Why would they do that to us? Oh, -2. I want -2. Sorry. Okay, let me redo that so I don't confuse you more. All right, so p of x over x minus 2 is equal to q of x plus 10 over x minus 2. All right? But I know that q of -2 is 6. So I'm going to replace this with 6. So p of x over x minus 2 equals 6 plus 10 over x minus 2. But what is x in this case? It's -2. So p of -2 over -2 minus 2 equals 6 plus 10 over -2 minus 2. There we go. So this is just a 4. Over here I get 6 plus 10 over -4. So that's 6 minus 2.5. 2.5. So that's 3.5. And what is 3.5 equal to? This. So I times by 4. 3.5 times 4 is going to be my answer. Do you want to see another one of those? Yeah, that's complicated. All right, so find the value of k such that the remainder is 12 when p is divided by x plus 1. So if I divide by x plus 1, what goes in the corner? -1. Right? So my coefficients are k, 5, 1, and 5. Everybody follow? Drop the k. K times -1 is -k. So this would be 5 minus k. So this would be k plus 5, or sorry, k minus 5. K minus 5. So this would be k minus 4. Everybody follow? Multiply that out. 4 minus k. Add those together. My remainder is 9 minus k. Okay? But what is the remainder? 12. So 9 minus k equals 12. So I'm going to subtract 12 and add k. And I get negative 3 equals k. We better do another one. That was nothing like the last one. All right. So if I take p of x and I divide it by x plus 6, I get a new function, q of x, plus a remainder of 7 over x plus 6, which means p of negative 6 is 7. That's the remainder. So I know that p of x hits the point negative 6, 7. When x equals negative 6, y equals 7. I also know that x plus 6 is not a factor of p of x because it gave me a remainder. So what happens when we plug in 6? So p of 6 over 6 plus 6 is equal to q of 6 plus 7 over 6 plus 6. But what is q of 6? It's listed up here as negative 5. And then I just solve for p of 6. So p of 6 over 12 is equal to 7 over 12 minus 5. So I just times this by 12. So 12 times 7 over 12 minus 5 gives me negative 53. So p of 6 is negative 53. Do you want to see any more of these? Do you want to see the other version where we did the synthetic division? No comment? Yes? No? Yeah? All right. Let's do another one. Okay. So we're dividing by x minus 1. So I put 1 in the corner. K plus 3 minus 4 plus 2. Drop the k. 1 times k is k. So k plus 3. 1 times k plus 3 is k plus 3. Add those together and I get x. K minus 1. 1 times k minus 1 is k minus 1. Add those together and I get, oh my goodness, k plus 1. That's my remainder, but I know that my remainder is equal to 5. So k plus 1 equals 5. So k must be 4. Yeah, those aren't bad. All right. Ugh. Get to work.